We try to study if before the earthquakes in general in the world, but in particular before these earthquakes occurred here in central Italy, there were some possible alteration of lithosphere, atmosphere, ionosphere, even some possible lithosphere, atmosphere, ionosphere coupling during the preparation of Amatrice Norcia earthquakes. We did a lot of studies and analysis, publishing 3 papers. The first one that we published was in pure and applied geophysics. The first author is Alessandro Piscini, and we analyze 3 atmospheric parameters, 3 basic atmospheric parameters. The temperature, in particular it was the skin temperature. Skin temperature is defined as the temperature between the layer of lithosphere and atmosphere, just in between the 2 layers. It's a theoretical definition, but anyway, it's an indication of temperature on the ground. Then we analyze also the total column water vapor in central Italy and total column ozone. Just these 3 parameters. It was very interesting to find that about 40 days before the earthquakes, the water vapor and temperature were anomalous for 2 consecutive days, were around 10-13 July 2016. After a few days, just 15 July 2016, total column ozone shows an anomaly also persistent of 2 days. But how we extract these anomalies, that's very important. There are several authors that implement different methods. Anyone, it's okay if there is a scientific base for the method. In this case, it's a method that is based on a climatological analysis. We collected the data from 1979 up to 2015, the day before the earthquake. With this amount of year, about 35 years of data, we calculate the mean temperature, the mean water vapor, and the mean ozone that is present in this area. Not only this, on where the earthquake have its nucleation, but it was very large area. All the central Italy was considered. In fact, the preparation area of an earthquake is supposed to be very much bigger. Normally we use the Dubrovsky area, that is an area that scales exponentially with the magnitude of the earthquake, so linearly with the energy released by the earthquake. So we characterize the value. What is the mean value? It's a standard deviation. Standard deviation is how much is the deviation of this value around this mean historically. We set a threshold that is technically 2 standard deviation above the mean, and it was inside this value before Amatrice 24 August 2016 earthquake, but for 2 days, that was said before, it was anomalous, and these days were about 14 days before Amatrice. Here you see the map of surface air temperature, especially made for this video, on 11 July 2016 at 23 UT, the same time analyzed in the paper. As you see, in the central happening, the absolute value of temperature was low, not high. But if you see this second picture, if we subtract the typical value in the 30 years before the earthquake, we see that the difference of temperature in the happening mountain was very high and higher than the other parts of Italy. Also in Balkan there is some high value with respect to the mean, but that could be due to the other reasons. And here you see a comparison between the absolute value and the difference value of temperature in the 2016 with respect to the previous years. So what I would like to underline is that what is important is not the intrinsic value, but the difference of the value with respect to the typical value in previous years. Then here is not possible to ignore the important question. It's a really very important question. In front of us, just behind this very nice climb of mountain, there is Castelluccio di Norcia that is totally destroyed by this earthquake, and Amatrice, that is more on that direction, unfortunately also is totally destroyed. A lot of towns around here are destroyed. You see in this picture collected in several towns like Pretare, that is just behind here. So you could ask, was it possible to predict this earthquake? As we found some anomalies before. To be honest, firstly we need to say we did this analysis after the earthquake was occurred. We started to work exactly on 24 August 2016. As you know, unfortunately in the night occurred the earthquake. In the morning we started to download the data and analyze the data. So we didn't found this result before the earthquake, first point. Second point, we did a statistics that is present in the paper that if you like, I invite you to read. You can use a QR code to download or the link in the description below this video. So, for the statistics, a significant number of time for magnitude 5 or 5.5 plus earthquake in central Italy, there is an increase of temperature and water vapor. But, for example, the total column ozone didn't show a statistical significance in this analysis, so it starts to show some weakness. Maybe this is due because the ozone is a shorter time series, don't start in 1979, there were no data, at least in the archive we used. So we started, if I remember well, from 2002, and this make the time series shorter. So that's could be one reason, or maybe the ozone is not sensible to pre-earthquake phenomena, even though there are several other reports from other authors, for example Tronin, that found the ozone to be anomalous before other earthquakes in the world. So maybe it just need to be studied better. So that's the point. We are not yet, unfortunately, ready to use this method in real time to make prediction. We need to refine still this method to be able to make prediction. And I say unfortunately, but we are understanding something on the preparation phase of the earthquakes. This is fundamental for predict one day the earthquake. We are not ready today, maybe in 10 years or 40 years this could be possible, and we hope this will be possible. Thank you so much for your attention.